Hello, my name is Ivan Taylor, and I'm from Policy Dynamics Incorporated in Ontario, Canada. And today I'm going to share a presentation that I gave this week to the African Space Leadership Institute on systems thinking. So I hope you enjoy it. So the title of the talk is Systems Thinking and its Relevance to Space Leadership. And the objectives of the talk are to help you understand the core principles of systems thinking, which are cause and effect relationships, feedback structures, and system maps. System maps is a new term that's starting to become very popular, and I like it. It's the term that's being used today for the old expression called causal loop diagrams. So when I talk about system maps and you read about causal loop diagrams, we're actually talking about the same thing. And then at the end, I'm going to introduce system dynamics, which is one method in the broader toolbox of systems thinking. But I'm not going to go into much detail on system dynamics, even though that is my specialty in policy dynamics. So what is a system? A system is a set of interconnected elements organized to achieve a function or purpose. So we can think of many systems. For example, a rocket launch system. But we're not that a rocket launch system is not really the kind of system that we mean. What we mean is socio-technical systems. So, for example, we might look at the decision-making process to launch a rocket as a system. So, most of the systems that we want to talk about are systems with a human in the loop. So, what are the characteristics of a system? Well, first, it has a purpose or a function. Second, it has boundaries. So we're going to talk about modeling systems, and you can't model everything. So you have to place a boundary around the system. And that's a very interesting thing because then you can see what is inside the system and what is outside the system. And what is outside the system can influence the the things that are inside the system, but we don't have direct control over the things that are outside the system. The things that are inside the system are interconnected. So interconnectedness is a characteristic of a system. And feedback and delays are major components for understanding the behavior of a system. However, a system, as we know, is greater than the sum of its parts. Uh, and, uh, and by that, we often find that it has emergent behavior that you wouldn't expect from looking at the parts. So that's what I mean by the system is greater than the sum of its parts. So let's look at linear and feedback thinking. So linear thinking is basically A causes B causes C, which is a cause and effect relationship in one direction. Feedback thinking is something like this. So A causes B and B causes A, and B causes C and C causes B, and C causes A and A causes C, In fact, A causes C causes A causes B causes C. So it's a circular feedback system. And one nice way to think about this is that the effect is actually the cause. So we have a cause and effect, and then the effect feeds back to it to be the cause of another effect. So let's look at cause and effect a little deeper. So there's two types of cause and effect. There's cause in the same direction. So in this case, we have national investment. And when national investment goes up, then technical achievement can go up, which is in the same direction. And if national investment goes down, technical achievement can go down. So these two things are moving in the same direction. And then, of course, we have opposite direction. So, for example, if budgetary strain goes up, national investment could go down. And if budgetary strain goes down, national investment could go up. So these things are moving in the opposite direction. The last thing we want to talk about is delays. And delays occur in the cause and effect relationship. So for example, technological achievement can lead to international prestige, but there may be a delayed reaction. So you might obtain a technological achievement, but not obtain the international prestige for a number of months or years. So let's look at system maps. System maps are combinations of reinforcing and balancing loops. So what are reinforcing and balancing loops? Reinforcing loops lead to growth or collapse, and balancing loops lead to stability or goal-seeking behavior. And we're going to show you quite a number of reinforcing and balancing loops in the rest of this presentation. And system maps help us think about systems without data or computers, which I think is very useful. So let's look at a system map for a fairly simple problem about space debris. And it's based on something called the Kessler syndrome, which talks about the accumulation of debris in low Earth orbit. And there's a problematic reinforcing loop here that debris leads to collisions between things in space, which leads to more debris, which leads to higher collision risk, which leads to more debris, which leads to more collisions. So this is a very problematic reinforcing loop. So could we think of possible balancing loops as solutions to this problematic reinforcing loop? Well, let's look at it. So here we have three loops, and we see that the Kessler syndrome debris loop is in the middle. It's a reinforcing loop. So we have this idea that if the success rate goes down, then the failure events go up, and then the debris creation goes up, and then the debris accumulation goes up, and then the collision risk goes up, and then the mission success rate goes down. So this is a reinforcing loop, and because we started with the mission success rate going down, and the further going through the loop led to further reduction in the mission success rate. Notice that we have two opposite connections in this loop. So what about balancing loops to compensate for this Kessler syndrome? So for example, on the right-hand side, you can see that we have failure events, and when they go up, then organizational awareness goes up. And when organizational awareness goes up, then preventive oversight might go up. And if preventive oversight goes up, possibly failure events would go down. And notice here that we have only one opposite connection, and it's a balancing loop. So then we look at the other side. On the left-hand side, we have debris accumulation. And if debris accumulation goes up, we might have possible regulations pressure. And then regulations pressure going up might lead to debris mitigation measures going up. And that debris mitigation measures going up might lead to collision risk going down. And then collision risk going down might lead to mission success going up. And then mission success going up would lead to failure events going down. And failure events going down would lead to less debris creation. And less debris creation would lead to less debris accumulation. So that's a balancing loop. And notice here that we have three opposite connections. And so a general rule of thumb is that reinforcing loops have an even number of opposite connections, and balancing loops have an odd number of opposite connections. So let's look at something more complex. We're going to look at space leadership. And I'm going to talk about the complex relationship between national investment and mission success rate. And I'm going to talk about three reinforcing loops, which are the intended consequences of the national investment. And then I'm going to talk about two balancing loops, which are in this case, the unintended consequences of national investment. So here's the model. Here's the system map. And we start in the upper right-hand corner with national investment going up, leading to mission experience going up, leading to technological achievement going up, which after a delay leads to international prestige going up, which leads to national investment going up. And this is the intended consequence that I mentioned. However, there's an unintended consequence that national investment going up might lead to budgetary strain going up, and budgetary strain going up might lead to national investment going down. So that's a balancing loop, which is an unintended consequence that you might not have thought of when you're looking at only the intended consequences. So then let's go to mission experience. So mission experience going up leads to the knowledge base going up, and the knowledge base going up leads to the training effectiveness going up, and the training effectiveness going up leads to the mission success rate going up, and the mission success rate going up leads to organizational momentum going up, and organizational momentum going up leads to mission experience going up. So that's another reinforcing loop, and it's got no opposite connections. And so since 0 is an even number, we can see that this is a reinforcing loop. So now organizational momentum going up can lead to increased stakeholder participation. And increased stakeholder participation can lead to increased stakeholder alignment. And increased stakeholder alignment can lead to increased mission success rate. And an increased mission success rate can lead to increased organizational momentum. So that's another reinforcing loop, which is a very nice intended consequence. However, there's a balancing loop. Stakeholder participation going up can lead to coordination complexity going up, and coordination complexity going up can lead to mission success rate going down. And mission success rate going down can lead to organizational momentum going down, and organizational momentum going down can lead to stakeholder participation going down. So that is an unintended consequence. That's a balancing loop that you might not have thought about when you thought about the positive expected consequence of increasing stakeholder engagement. So this is, again, a slightly more complex systems map. So let's put it together. Notice that in both of those maps, mission success was in both of them. So we can connect these two maps together through the mission success. So we have R1, the reinforcing loop one is I'm going to call investment and prestige loop. B1 is the fiscal constraint loop. R2 is the innovation and learning loop. R3 is the stakeholder engagement loop. B2 is the participation friction loop. R4 is the debris and failure dynamics loop. B3 is the resilience through oversight loop. And B4 is the governance-based mitigation loop. So it's often nice to name these loops so that they give a more expressive understanding of what's happening. So now we put it all together and we now have this very complex system map. And we see that the space leadership portion is at the top and the Kessler syndrome model is at the bottom. And in the middle is the mission success rate, which I think is very good, a very good model because that's the goal is to increase mission success. So what are some applications of systems maps for the African Space Leadership Institute? So you can use system maps in strategic planning, in policy formulation, in stakeholder analysis, and in technology development pathways. And where does system dynamics fit in? Well, system dynamics is a computer simulation method for modeling system behavior over time. So this is where we get into data and computers to model systems. And system dynamics is mostly quantitative, but it builds on qualitative tools like system maps. And it involves something called stocks and flows. And stocks can be thought of as the state of the system at any point in time. And these are accumulations. So two examples of accumulations are knowledge, which is a qualitative stock, and debris, which is a quantitative stock. So you can see that stocks and flows don't have to all be quantitative, but they do have to be measured. So somehow we have to measure the increase or the state of knowledge. And then flows are the ways the system changes over time. And there's inflows and outflows from the stocks. So for example, experience is a qualitative inflow to the knowledge stock. And collisions is a quantitative inflow to the debris stock. So let's finish up with some ideas about going from insight to action. So system maps enhance understanding of complexity, anticipation of unintended consequences, and multi-stakeholder communication. And I just want to make a call to action to apply system maps in strategic problems framing for the African Space Leadership Institute. So here's some recommended readings. So Thinking in Systems by Donella Meadows is a book, and it's a very good book, and it includes both systems thinking and causal loop diagrams, it calls them, and system dynamics, stocks and flows. Fifth Discipline is also a very good book by Peter Senge, and he has a lot of system maps, which he calls archetypes. And these are common systems that occur in many, many different places. And he also talks about system dynamics, and system dynamics is actually the fifth discipline. So he finishes the book by talking about system dynamics. He also talks about learning organizations. And so I think that would be a very useful book for the African Space Leadership Institute. And next, there's Systems Thinking for Social Change by David Peter Stroh. And I worked with David on a project, and this is a very good book. He also uses archetypes, and he tries to find the unintended consequences that can occur when they're causing the intended consequences to stall or not achieve the goals they want. So he starts every study with a statement, um, why, even though we're spending so much effort and time and money, is the system not getting better? And that's because of possible unintended consequences. There's also a number of online resources. There's a lot of online resources. Here's a few. The Systems Thinker is a very good magazine. It's available, I think, at the systemsthinker.org website, and there's lots and lots of very good articles in there about systems thinking. They're no longer publishing new editions, but there is a very good archive at that website. Of course, the System Dynamics Society is a very good place to find materials on systems mapping, systems thinking, and system dynamics. And the Water Center is another great place to look for systems mapping. And it has a lot of information about something called group model building, which is a technique whereby you get a lot of people in one room together, and they build a system map together to come to some consensus about what the issues are with the system. So I'll end with a final thought that the ability to see the whole is more valuable than the mastery of the parts. Thank you for your attention. And if you have any questions or comments, you can contact me at ivan@policydynamics.ca. Uh, I'll be posting this on my LinkedIn page, and you can reach me by connecting with me as on LinkedIn, or you can email me. I'll also be posting this on my YouTube channel, and you can subscribe to my YouTube channel if you want to see more of my work. So thank you for your attention.